All right, geometry. We are continuing here with this section on 3-2, but now we're going to be looking at practice B. Again, this is out of the book that we have. All right, so name Butler. That's my name, not yours. You write your name. Now we're doing this without notes, but it's the same general idea. Let's see what's going on. Okay, so I have find each angle measure. I got this angle is 133 degrees, and I got this angle is angle 1 there. And I noticed that these are same side interior. How do I see that? Well, let's do a couple things. First, let's highlight this transversal. So, okay, so there's a transversal. And that means that they're both on the same side and they're interior. That's that U-turn kind of action. So we go down this line, we U-turn, then we U-turn, and we're coming back up the line right there. Okay, so we got 133 and angle 1. And I know that together in that U-turn, it's going to add up to 180 degrees. So I'm going to have two things that add up to 180 degrees. So we have 133 plus the measure of angle 1. Now to figure out measure of angle 1, it's pretty, simple logic here. We subtract, and then you get measure of angle 1 equals, and this would be 47 degrees. And that's it. That's it. Yeah, it's easy, I guess you could say. Let's take a look at the next one. Let's change up the color here a little bit. So we got angle 119 degrees for this one. And then we have this angle 2. And the question is, well, it's either going to be one of two things that we're starting to notice a pattern here. Either it's two angles are equal or congruent, or they're supplementary and they add up to 180. And the question is which one? In this case, we're going to be looking at a corresponding angle. Because notice that, we're looking at one from each group, and if I were to cover one up, you look at that angle 2, it's in that top part of that cluster. And then if we were to look at the same thing over here at the 119, it's also in the top section, I guess you could say. So together, they're corresponding. So this is corresponding angles. And those are equal. So angle 2 is 119 degrees. That's it. Measure of angle 2 equals 119 degrees. I guess I could have written my answer down here as well. 47 degrees. All right, let's keep on going. And what is it asking me to find? It looks like it says angle ABC. So I'm looking for this x degrees here. Now this one's not exactly obvious, but it's still pretty easy to do here. It comes back to that relationship when you're looking at the transversal. Let's color code stuff. Let's color code stuff for ourselves. So here's our transversal. And let's say I were to do blue and red for the colors. So blue angles, this 83 would match this one right there. And then by alternate interior, I could go across the transversal, and those two would be equal as well. So all these blue ones would be equal, either by vertical angles corresponding, alternate interior, alternate exterior. They're all equal that way. And then if I do the other angles that go with the x, so here's the x, and this other side of it, the vertical angle, that would be equal to it because vertical angles are equal. And then over here, this alternate interior angle would be equal, and so would this corresponding angle. So we got all kinds of options, blue and red. But what I notice right now is I have one of each. I got this 83 and this x. And the blue and red together make a straight angle, which is 180 degrees. So that means it's like a supplementary relationship. So I'll have x plus 83 degrees is going to add up to 180, a supplementary relationship. All right, so let's see what we have happening. We're going to subtract 83, and then we got x equals, well, let's see what x equals. This is 97. So measure of angle ABC is 97 degrees. Piece of cake. Okay, now a little more algebra happening. Not too bad, though. So I'm looking at this angle here and this angle there. And those are, well, let's see, where are they? I don't know. Here's our transversal. We're on opposite sides of the transversal, and we're inside between these two parallel lines. So that would be alternate interior angles, and those happen to be congruent. So that means that, what was that, 8x minus 34, I think? Let's erase it just in case. I'm not sure. Yep, 8x minus 34. So we got 8x minus 34, and then 5x plus 2, and those are equal. All right, from here it's just a lot of algebra again, so I'm going to add 34, subtract 5x, subtract 5x. I'm doing kind of two algebraic steps in one there. It's really one, but, you know, kind of combination. Then we got 8x minus 5x is 3x, and over here we got 0, and that's 0, and then the other part is 36. So if I were to divide, I would get x equals 12. Cool. So there's my answer, x equals 12. Wait a second. It says DEF. So they want me to find this angle here. So I got to plug it in. Now I could use either one because they're equal. It doesn't really matter. I'll go ahead and use the one that they gave me, 5x plus 2. So I have 5x plus 2. That's really 5 times 12 plus 2. And that's 5 times 12 is 60 plus 2. And then that's 62 degrees. So 62 degrees. Awesome, awesome, awesome. Okay, stop the video. Or not stop the video, just stop my annotations. And let's go down to the bottom here. It's a proof, I believe. It is. Oh my goodness. It's a proof. Okay. What do we do? Oh, we just got to fill it in. No big deal here. So let's see what's happening with each of these pieces. So for part A, it says measure of angle 1 plus measure of angle 3 equals 180 degrees is what we got to prove. So that's going to come somewhere down the bottom. And it's telling us that these are parallel, which we can also see in the picture. Those two little arrows mean parallel. All right. The first thing says linear pair theorem. Oh, that means that these two right here are supplementary. Okay, so let's do that. That means that angle 2 and angle 3 are supplementary. And actually, you know what? We can go even further. Linear pair theorem lets us get right into the algebraic stuff. So measure of angle 2 plus measure of angle 3 equals 180 degrees. Cool. And what's going on in the next one? It says angle 1 is congruent to angle 2. Well, if I look at these two, look at this 1 and this 2, those are corresponding angles because they're both in like that top left location on two separate clusters made by a transversal and parallel lines. That's a long sentence to say, but they're corresponding, they match. So that would be the corresponding angle, and there's actually, it's not a theorem, but we call it a postulate. That's like a beginner's theorem, a baby theorem. So a corresponding angle postulate. Cool. Next, definition of congruent angles. Well, when we have congruent and we say definition of congruent, that means that we're changing to equal, or we're going the other way. So measure of angle 1 equals measure of angle 2. Whether you're going from equal to congruent or congruent to equal, that's definition of congruency. All right, now here's where it's awesome. So 1 and 2 are the same. Let's highlight these real quick. 1 and 2 are equal. And there's a 2 right here. So I can swap out that 2 for a 1. And then, if I take this out and replace it with a 1, it'd be measure of angle 1. And it'd have plus measure of angle 3 equals 180 degrees. Guess what? That's my final step. That's what it said to prove. And I just did that. What did I do? I replaced something, so that's called a substitution. Substitution. Done. All right, I'm going to end the video there because I really don't want to make this go too long. I hope that was enough. Again, you guys can watch this at home, in class, on the Chromebooks, wherever you need to, and whenever we have time and it's appropriate. All right, that's it. Also, remember, homework, and I sent that out to you guys, and it's also listed up on the board if you need. All right, that's it. Bye.